Before we go looking for the herbal fix, we need to get a handle on the problem. So first, how seriously should we really be taking the threat from climate change?
I lecture on climate change, it's my job therefore to keep up to date with the science as much as I possibly can, and I do. The cause of the heating at the present is carbon dioxide. The source of the carbon dioxide is man's activity. The rate of rise is dramatic. This is going to compromise the planet's ability to support a rich variety of life, and that will compromise the planet's ability to support us.
99% of sensible scientists agree on a consensus that these things are happening. There's a 1% of dissident scientists who believe it's not. Now the point is they're getting media attention on a 50-50 basis.
There are those who think it's already too late. The wire is very close.
Certainly in the next 20 years we're going to see severe problems on the planet, I think. So I think if people are talking about 2050, I think we're going to see it in 2020.
The thing that seems to have most effect on people is the idea of what legacy we're leaving for the next generations, and the fact that if we're not careful we will leave an environment that is uninhabitable.
Could it really be that bad? Well, New Scientist published this map in 2009. It shows how the world will look within my son's lifetime, and possibly mine, if we carry on as we are. The temperature has risen by 4 degrees, and the whole of this area is indeed largely uninhabitable. Then, last November, The Independent predicted a 6-degree rise.
6 degrees centigrade isn't just a bit worse than 2 degrees centigrade, or a bit worse than 4 degrees centigrade. 6 degrees centigrade is a death sentence for human civilization. Doesn't mean to say there won't be lots of human beings left over after a 6 degree centigrade rise, but I assure you they won't be having much of a time.
It looked like the 99% of scientists were winning the argument, but next thing along comes ClimateGate, parts 1, 2, 3 and more. And a lot of potential eco-warriors went back to being mere eco-warriors. By December, when the much vaunted Copenhagen summit proved to be a damp squib, it was starting to look as though the skeptics were winning.
Having pondered it all a lot since Copenhagen and looked at the views of the skeptics, looked at the mainstream, you know, I tend to think you have to give quite a lot of credence to people like James Lovelock and James Hansen, who say that it's quite a lot worse than mainstream science says. And I'm fairly persuaded by that, in which case there may be an awful lot of change already in the system, which we're going to have to react to, and it is pretty terrifying, frankly.
It depends really on whether countries actually do what they promised. And what it shows is that we've got further to go. We didn't get a legally binding agreement. And you're right, in the end, the scientists have to listen to people going around the table putting their offer down and then say, well, this is what it means in terms of temperature change. Are you okay with that? And the fact is we've got some way to go.
Some countries involved, like the United States, have offered targets which are way too low, but I wouldn't say that necessarily will add up to what the United States will contribute, because the US is such a big and vital society and there's so many other things going on below the federal level. So I think you might get strong leadership from the US, but not necessarily at the federal level.
And strong leadership from the US would be welcome, not least because their emissions are currently the highest in the world, as is their consumption. And that bloated map warns us that the climate is not the only potential threat we're facing.
It's generally accepted now, I think, that most of the oil that's left in the earth is going to be difficult to get out.
When we look back, we'll probably see that we're about at peak oil now, which of course doesn't mean that the oil is about to run out, but it means that every next barrel is more expensive to get out of the ground, basically, and we're past the era of cheap energy and the lifestyle that it supported.
Oil, gas, coal are now essentially sunset industries, and that's going to create enormous pressure on innovation for other forms of energy.
It's not just fossil fuels, and then of course they're linked to climate change issues, but also the trace metals and so on that we think we're going to be able to do all the techno fixes with. So many of those are in short supply. We think we're going to be able to invent ourselves out of trouble, but we're going to hit resource shortages in many ways.
And it's not just mineral resources that are running out, as the RSA heard recently in a debate on food in a world without oil.
Agriculture is both about energy, but also has now become reliant upon energy in the form of oil. But probably the single issue that's going to bring the current model to its knees quicker than oil is water.
Water is quite a big threat because even the UK is suffering problems from place to place.
Land use, soil structures, Any assessment of soil structure shows the world's soil's in distress. Not everywhere, some are wonderful, but in distress generally. Even in rich Europe, even in rich Britain.
We might get 9 billion people on the face of the earth, and I think we know that we don't have enough resources simply to have a simple model of development for that number of people.
So really it's irrelevant whether climate change is happening or whether we can do anything about it or not. We have to change the way we do things anyway. Ecologists call the problem overshoot, and it works like this. This line is the world's carrying capacity, the total amount of life that the planet can support. And this is consumption, still growing strongly at the moment. If we're very lucky, mankind will see where it's heading in time and ease off before we hit the limit, then keep consumption at a steady state just within the planet's support system. But if we overshoot by trying to consume too much, we'll actually damage the system. So when consumption finally starts to fall, the carrying capacity drops with it. A potentially catastrophic situation. Plus there's another factor. The depletion of natural resources is often shown as a bell shape. Extraction, in this case of oil, starts slowly, then increases to a peak around about now, then declines in roughly mirror image as the resource runs out. Some experts suggest we should draw the graph the other way up, to show that the early stages are an easy downhill ride, and there's an increasingly steep climb out as reserves get harder and harder to extract. But even this doesn't tell the full story.
Oil importers can only purchase the oil that the oil producers don't use themselves. Oil subsidies by the oil producers to their populations give them little reason to conserve. Their internal use will continue to grow, leaving less for the rest of the world. Brown and Fouché's work shows that net oil exports will be squeezed from both sides. Top-line production will decline, and the exporting country consumption will increase. Oil importing countries will not get all the oil they do now. To them, world oil production will look closer to the white line.
And the closer we get to 2040, the more problems we're going to have. A major price hike or some interruption in supply, and suddenly we'll find we can't grow or deliver food or indeed function at all.
I think one of the key things that we need to confront is a moratorium, a global moratorium on fossil fuel extraction.
I don't necessarily even think we have the right to use up all the oil we can find. What gives us that right as compared to subsequent generations?